Hello everyone, welcome to this channel. In this video, I have this question on a board that you're going to solve. So the question says, replace the two forces with an equivalent force movement system at point J. Okay, so we have the 40 newtons force here and then the 70 newtons force here. So to replace these two force system with what an equivalent force moment system at what point G. So what I'm supposed to do is to find the resultant of what these two forces and then replace them what by that resultant force at what point G, and then find the moment that will cause by these two forces and then replace the entire moment what by the resultant moment and then indicate that what point what G. So that's what we're going to do. So we're going to start by finding the resultant force. Okay, so let's look at that. Okay, so before you can get the resultant force, you must find the components of for the 70 Newton force and then the 40 Newton force. So let's name the x component of the 70 Newton force as F1x, and then let's name the y component as F1y. Okay, and then let's name the x component of this 40 Newton as F2x, and then the y component as F2y. Okay, so now let's find this component. Let's start with the 70 newtons force. So let's take cosine of the angle. So we are going to have cosine of 16 degrees. That will equal to F1x over 70, right? So we're going to have F1x to be equal to 70 cosine of what? 16 degrees. But you notice that it is pointing in the negative x-axis direction, so that was negative. So let's find F1 y. That also do what? Minus 70 sine 16 degrees. It is pointing downwards, negative y-axis direction. So let's do same for the 40 newtons force. That's we're going to have cosine of the 70 degrees. That will equal to F2x over the 40. So we're going to have F2x to be equal to minus 40 cosine of what? 70, right? It's pointing the negative x-axis direction. We're going to have F2y also to be minus 40 sine of 70 degrees, negative y-axis direction. So now let's find the resultant of what the components. So you're going to have sum of forces in the x-axis direction. Okay, let's look at that. So we are going to have minus 70 cosine of what? 16 degrees minus 40 cosine of what? 70 degrees. Okay, so let's see what you're going to get. So we have minus 70 cosine of 16 degrees minus 40 cosine of what? 70 degrees. So that gives us a value of minus 80.969 newtons. Okay, that's what you're going to have. Let's consider sum of forces in the y-axis direction also. You're going to have minus 70 sine 16 minus 40 sine 70 degrees. So let's see what you're going to get. Minus 70 sine 16 minus 40 sine of 70 degrees. Minus 70 sine of, okay, I made a mistake, mouse function. Okay, so this will give us the value of minus 56.882 newtons. So now let's find the magnitude of these two forces. Okay, so let's see the magnitude of the resultant force. That will equal to the square root of, let's ignore the negatives. You're going to have square root of 80.969 squared plus 56.882 squared. So let's see what you're going to get. We're going to have the square root of 80.969 squared plus 56.882 squared. So that gives us a value of 98.952 newtons. Okay, so that's the magnitudes. Now let's find the direction. Okay, so let's look at that. So both components are negative. So if I'm to indicate it on the xy plane, I'm going to have the positive x as you see in the negative. The positive y. And since both components are negative, that means our resultant force is going to be here. Okay, all right. So now let's measure the angle it will make with the x-axis. Okay, in this case, the negative x-axis, and then let's measure in the counterclockwise direction, which means we are going in this direction here. So you want to find this angle here, theta. Okay, you want to find theta. So that will be tan of theta equals to, we are going to have this to be the direction of this should be the x component, this should be what? The y component. So this will be fx, this should be what? Fy. Okay. So now, tan of theta equals to what? The opposite side, which will be fy over what? Adjacent fx. Okay. They are both negative, so the negative signs will cancel out. So we're going to have tan theta to equal to 56.882 divided by 80.969. Okay, so now let's look out 78. Tan theta will be equal to, we have 56.882 divided by 80.969. So this will give us a value of 0.703. So let's find tan inverse of that, of 0.703. So let's see what I'm going to get for theta. That gives us a value of 35.089 degrees. So that's the value for theta. So now I want to find the angle that the resultant force makes with the positive x-axis, okay, which will be this angle here. Okay, this angle, this angle here, okay, from the positive x-axis to where the resultant force is. Okay, so let's name that angle here alpha. So our angle alpha now will report to what? You have 90 here. That's that was 180 plus what? Theta. So let's have alpha to equal to 180, okay, plus 35.0089. Okay, so let's have 180 plus 35.089. So that gives a value of 215.089 degrees. Okay, so that will be the angle that the resultant force will make with the positive x-axis. Okay, so now let's find the resultant moment that you are going to put at what point D. Okay, so let's look at that. Okay, let me keep this. Let me write the angle somewhere here. Okay, so alpha equals 215.089 degrees. Okay. All right, so now let's find the moment about what point G. Okay, starting with the component of the 70 Newton force. Okay, so some of moment about point what G. Okay, so now let's consider the x component. Okay, so the x component, this will be the line of action of the force, right? And we know moment is what force times what perpendicular distance, and its perpendicular distance will be this distance here, right? So you have to find that distance, and that distance is what is 75 mm minus what 60 mm. And you have to convert from mm to what meters, right? So 75 minus 60 will give us 15, and then 15 times 10 to the power minus 3. give us what 0.015. So we've converted 15 millimeters towards meters, and then that gives us what 0.015 meters. So this component here, okay, this S component here will cause what? Will cause a counterclockwise moment about what? Point G. So that's what positive. Okay. We are taking to what positive. Okay, that's my positive direction, counterclockwise. Okay, so now let's find the moment. Okay, so we are finding the moment for F1x. Okay, so that's going to be F1x multiplying what 0.015. Okay, so what about the y component? So for the y component, this is its line of action. Okay, so this will be its perpendicular distance from point G. Okay, all right, so let's see. That will be, we can also trace it from here like this. I can also measure the vertical distance. It's all the same. So that's what this 80 mm here. So let's change it to meters. So that's what 80 times 10 to the power minus 3. That gives us 0.08. So this force here is going to cause a clockwise moment. So that was negative, right? So that will be minus F1y multiplying with 0.08. Okay. So now let's continue. If you consider the S component of the 40 newtons, you see that the line of action is passing through point G. So what that means is that that force component is not going to cause what any moment about what point J. Okay. So the moment that this force will cause will be zero because there will be what no perpendicular distance. So let's consider the y component. This is what F2y. F2y will also cause a counterclockwise moment, which is what positive. And its perpendicular distance, okay, will be this distance here, right? Which will be what? 60 mm plus what? 80 mm, which will be what? 140 mm. So 140 millimeters to meters will give us what? 0.14 meters. Okay, so let's look at that. So that will be plus F2y multiplying with 0.14. Okay. So now let's substitute the values in there and then get our answer. So you know F1x, okay, to be what? Minus 70 cos 16 degrees, right? But in this case, we ignore what this negative. Okay, we don't include this negative. Okay. So we are going to have 70 cosine of what? 16 degrees multiplying 0.015. Okay, and then minus Fy, which is 70 sine 16 multiplied with 0.408. Okay, and we know it is negative, right? Because it equals what? A clockwise moment. Okay, plus F2y. These are F2y, which will be causing the counterclockwise moment. So that's also positive. So that value is 40 sine 70 degrees. Okay, multiplying what? 0.14. So now let's find the resultant moment. Okay, let's find the resultant moment. We have 70 cosine of 16 multiplying 0.015 minus 70 sine of 16 multiplying 0.08 plus 40 sine of 70 multiplying 0.14. So that gives us a value of 4.728 Newton meter. Okay, and because the value is positive, that means what we're going to have was a counterclockwise moment, right? So we can replace the entire moment, okay, with the four that we found. Both components were negative, so our resultant force will be somewhere here, okay, right? And then the moment is what? A counterclockwise moment. Okay, so let's indicate it something like this. Counterclockwise. Okay. And the value is what? 4.728 Newton meter. Okay, and then you find the value of whatever comes first to, so you can write that value to here, and then you can indicate the angle from the positive x-axis also. So this is how to go about this question. Thank you very much for watching this video. If you haven't subscribed to the channel, please use this time to subscribe and also like the video.